Okay, so this is another snow day video about quick and basic complex numbers. So you need to know just a little bit. So you already know how the Cartesian axes work. So if I'm, 1, 2, 3, 4, 5, 1, 2, then this point is at 5, 2. The exact same structure is used to put real numbers where the x's go and pure imaginary numbers on the y-axis. And so this point would be read off as 5 plus 2i, meaning 5, the real number 5 that you know and love, and then 2 times I, where I is square root of -1. Okay, so this is in this orthogonal direction, or perpendicular direction. And so, well, I'm sorry, my drawing isn't perfect, but this point right here is 5 plus 2i. Let me give you some more examples. If I were right here, this would just be I plus 1 plus I. Over here would be 2 plus I. Over here would be 1 minus I. This would be minus 1 minus I, and minus 1 plus I. Something over here, I could go -3 down 2, it would be minus 3 minus 2i. Then up here you get 3 plus 2i. If you have something where the only difference is a plus versus a minus, those two are called complex conjugates. You don't need to know that, but you may hear that somewhere. So those two would be complex conjugates. That's if the two numbers add together to give you a real value. They're exactly the same. One has the same exact imaginary plus versus imaginary minus. So you add them together, it brings you back to the real line. Okay. Alright, so that's that. Let me get rid of this on my screen for a second. Oh, I'm sorry, I'm in the wrong. I can't do that right now. Normally I can pause. Alright, so I just do this. Alright, so complex number is a plus bi, where a is real, b is real, and this quantity bi is called imaginary. So imaginary number is a real value times I. I want you to think initially as I, as if it's a normal variable, okay? So I want you to think, to add, pretend I is just a variable. Okay, so for example, 3 plus 7i is an imaginary number, and you're adding 4 minus 6i. That's really easy, because 3 plus 4 is 7, and 7 minus 6 is 1. So you just add it, pretend like it's a normal variable. Alright, that's easy. But what happens if you need to multiply? And that's where the thing gets a little more complicated. Okay, so to multiply, okay, use FOIL, the FOIL acronym, first, outer, inner, last, then collect i's. I squared is -1, and collect the real terms. Okay, so let me give you an example. So that's not that bad, it's just a little tedious. 2 plus 3i times 4 minus I. So we do the FOIL. First, we just pretend it's a variable. 2 times 4 is 8, outer, minus 2i, inner, plus 12i, last, minus 3i squared. Don't forget it's I squared. So in the next line, you can combine the i's, but the minus is going to flip because I squared is -1, so this becomes plus 3. Then you get 11 plus 10i. Okay? Except that's not what I got. I got 5 plus, because did I make a mistake? Let me double check. Yeah, it's correct here. It's wrong in my notes. So I guess I'll correct my notes before I circulate them. Okay. What if I want to do division? So dividing is just as easy, but you just got to keep your wits about you. And you got to learn a small definition, which I just told you, but I'll tell you formally. To divide, you must multiply numerator and denominator by the complex conjugate. And you want to know a plus bi and a minus bi are each other's complex conjugates. Okay, so how do we do this? I'm going to try this, multiply top and bottom by the complex conjugate, and then you have to use the same technique we used in the last example. We have to do FOIL. So F is 32, O is minus 4i, inner 24i, and then plus 3i squared. Alright, and then we do the denominator. First, 8 times 8 is 64. And if you can see that we don't need to do the O and the I, that's great, but some people may not get that. I'm going to go ahead and do it. O is 8i, 8i is in the inner. There's too many i's, so FOIL. And then we're going to get minus I squared, so these pieces drop out. I'm going to get rid of this comment so that I can continue the problem. Okay, so I'm going to get 32 minus, I'm going back to here again, minus 28i, and then the I squared becomes a negative. Okay, this I squared becomes a negative, but it's minus, so we're going to get 64 plus 1 on the bottom, or 65, and then what's 32 minus 3 is 29 minus 28i, so that's the correct answer for the problem. I highly recommend in this type of problem that you refer back to Wolfram Alpha to check your work if there's a homework problem, because these are just kind of nasty. They're not difficult, they're just tedious, and it's very easy to make a mistake. So please check your work on the computer. Okay, so this will come up occasionally, but not much until Calc 3 or 4 or complex variables class, but I want to tell you the following thing to be very, very careful about. This is a common trick people use to tease each other. They try to say, oh, well, we can put the negative 1 and the negative 1 inside. So this is not true. You cannot put these two underneath and then say it equals to 1. Why? This is completely wrong logic. And the reason is that the square root of a times the square root of b equaling the square root of a times b is only true if a and b are positive, or if just one is negative. Obviously, if one of them's 0, you're okay. Okay, but or 1 or both equals 0. That's very silly. Okay, but it doesn't work if they're both negative. And when they teach you this rule, they just neglect to tell you that, because it's just, they're like, okay, look, we're just not going to go there with these kids. We want them to know that square root of 3 times square root of 4 is square root of 12. So we're just not going to bring into this discussion the fact that if they're both negative, the whole thing breaks. Okay, but it always was true. Like, it was always true that it would have broken, but it was a big lie that nobody bothered mentioning it to you because they just didn't want to go there. Okay, so that's just a little white lie your teachers told you when they gave you this formula, because they just didn't want to complicate your life. All right, this is just I times I, which is I squared, which is negative 1. Okay, and I think that is enough of that, and we're going to be ready for the next video pretty soon.